Hi, everyone. It's a minute or two early, but just go ahead and get going. Or not really get going, but I'm just going to start talking to you. I've been the last session of the day is good and bad because thankfully you guys are all here, so there's not no one. But it's also I've been having to anticipate this all day long, which is only a little bit nerve-wracking. But thank you all for being here. If you're standing in the back, not a lot of this is actually pretty open, but this session audio stuff is really cool. So if you're having trouble hearing me, definitely use it. I tried it out earlier today, and it was great. So really helpful. OK, so we'll just go ahead and get going. So what we're here to talk about today is securing integrations using the OAuth 2.0 JWT Bearer Flow. If you are curious of why I just said the word JWT, and that is nowhere on the screen, that is because that is how we pronunciate the abbreviation JWT. We pronounce that as JWT. That's actually, the acronym stands for JSON Web Token, but when you're talking about it in terms of this flow, you say it as the word JWT. So just so if you're, future reference. At the end of this, please fill out the survey. It's super helpful, helps me know if I did a good job. I probably didn't, but it's still helpful to at least have it for the record. So I'm Clay Chips. I'm a director of Salesforce engineering at a company called Steampunk. We're a technology consultancy based in the Washington, D.C. metro area. We use a trademarked methodology that we call design intelligence. We use human-centered design focused with industry-proven delivery methodologies and industry-leading technology to deliver what we call quality at speed for our US federal government clients and missions. So that's our industry we're in. If you're interested, I'd love to talk more about it later, but that's not the focus of why we're here. We're here to talk about the OAuth 2.0 JWT Bearer Flow. And so we're first going to talk about what it even is. And so what it is a couple of things, but it's mainly an authentication method. So it's going to provide a mechanism for a source system to prove its identity to a target system. You can think about this in simple terms as it answers the question, who are you? It also provides an authorization method, which is providing a mechanism for the target system to grant access rights to the source system, or otherwise answering the simple question of what can you do. So it's answering kind of two halves of this, right, which is who are you, and now if I know who you are, what are you actually allowed to do inside of my system? This is a server-to-server authentication method, so there's no user involvement. We're using predefined parameters between two server systems. And Salesforce is going to support both inbound and outbound authorization for this. So if you are trying to connect Salesforce to another system, or you want another system to connect to Salesforce, and it can be Salesforce to Salesforce, it can be external system that isn't Salesforce to Salesforce, or the other way, any combination is supported. But the main thing is there's no user involvement. So this wouldn't be something where you're wanting a user to log in as someone. This is two servers that you're wanting to exchange information. And so why would you want to use it? I kind of talked about it a little bit on the last slide, but you're probably wanting to do an integration, right? You're wanting to connect two systems together. Maybe you're wanting to make a call out into another system. You're wanting to retrieve data from another system, right? You're wanting to connect two systems, maybe two Salesforce orgs, maybe Salesforce org and a non-Salesforce instance. But it's going to provide a standardized and widely accepted method for those two systems to interact with each other. And what I mean by that is OAuth 2.0 is a specification that's governed by a council that has nothing to do with Salesforce. So whenever you use this, you aren't using something that's locking you into the Salesforce ecosystem, or if you go to another system, they're going to be like, oh, we don't use that. This is industry standard. It is platform agnostic. And so if you want to connect to another system that's not Salesforce, you have a high level of confidence that that other system is going to be able to speak the same language, so to say. It also has a lot of security benefits. It is not a username and password-based authentication method, which is usually a huge bonus for most security shops inside of organizations. There's a lot of reasons why username and password authentication is not great. It also is going to allow you to differentiate between user logins and the integration usage, right? So whenever you actually look at login history in your org and you're looking at maybe a service user that you specified, you're actually able to tell, hey, what was that user who logged in maybe via the UI? And you can also tell which integration did they log in as. And kind of going on that same topic, it's also going to provide you a level of access control, right? You can actually specify different scopes of access for each of those integrations and monitor the usage of them. So it kind of gives you a more granular level of control over the integrations that you're making. And it's actually really cool. I won't be showing it today, but you can actually even monitor the usage of those. And let's say this isn't always best practice, but let's say you had one service user that's connecting to multiple systems, and maybe one of those systems you think has been compromised. You could selectively shut down access to just that one system without impacting all of the systems that your service user connects with. So this gives you tons of benefits over maybe just a traditional username and password-based authentication. So to kind of now get into a little bit about kind of nuts and bolts, right? This diagram is super helpful if you've never used this before and you go to implement it and you're kind of confused on where all the pieces should go. On the left-hand side, we're going to kind of show a source system. This is just an example, but it hopefully lays out all the pieces. On the left-hand side, we have our source org. So this is a system that we're wanting to initiate a call out from to the target org on the right and get data from that target org. And these are all the pieces that you need from a setup perspective to make that happen and how they depend on each other. So whether I'm using an Apex callout or an external service action in Flow, I'm going to reference a named credential. That named credential relies on an external credential. That external credential is then going to make the authentication handshake with either a connected app or external client app, depending on which one you want to use, external client app being the newer of the two, right, to that org. And then the external credential relies on certificate and key management. We're going to get into more in that in a little bit. But as we go through the presentation, and I'm going to kind of show the basic setup inside of setup on how to do this, and then I'm going to talk about why it works. This is a great thing to come back to, and we're going to reference it back at the end. OK, so to kind of get into how we actually set it up, the first thing we're going to do inside of our source org is we're going to create a certificate bundle inside of certificate and key management, again, in our source org. I just created a self-signed one inside of the org for the purposes of this demo, just to kind of keep it simple. And then as soon as I created that, don't need to do anything else here, other than we do need to download the certificate from this, and we're going to use that in just a second. We're now going to switch over to our target org, and we're going to create an external client app. I just mentioned it, but this is the same thing as a connected app. If you're more used to that, it's just the newer iteration of it. Lots of nice benefits with it, but if you're used to that terminology, that's the equivalent of what this is. Other than setting up the basic details of like the name that I didn't show here, really the only key thing that you need to specify here is which scope you want. And so I just talked about that access control and scopes. This is where you're going to give a little bit of determination around whenever that source system calls in, what it's allowed to do using this external client app. And so in this case, I'm only giving it API access. I'm not giving it anything else over that. And you could modify that based on your use case, but I'm just keeping it simple for this. And then the one key thing is if you're using the OAuth 2.0 JWT Bearer Flow, you must choose the perform request at any time, also known as the refresh token scope. That's absolutely required for this flow to work. So that's not an option. That's the reason I didn't mention it. You have to have that one. And then other than that, the only other thing we need to do in this setup is obviously check the box that says enable the JWT Bearer Flow. And then it's going to prompt you to upload a certificate. This is where we upload that certificate that we just downloaded from the source org. Now, if you're kind of curious at the moment, like, what is this certificate even doing? I'm going to get into that in a minute. But for right now, we just upload it. We then switch back to our source org, and from here on out, we're not touching our target org ever again. We've done all the work in the target org we need. In the source org, we're now going to set up our external credential. If you're used to using legacy name credentials, you would do all of this inside of the legacy name credential, but I'm using the next generation of the name credentials, which splits the name credential and the external credential in two. So we're going to set up the external credential first. We're going to choose the authentication protocol, which is OAuth 2.0. Obviously, JWT Bearer Flow as the authentication flow type. And then the identity provider URL, this is standardized for Salesforce other than the my domain portion. So obviously, I have my sandbox domain in there. But the actual suffix, that's standardized. And at the end of the presentation, I'll have a list of resources on where you find that out on the Salesforce documentation. But pretty prescriptive on that. And then we'll fill out our claims. The issuer that you see there, that is the consumer key that comes from the external client app from the target org. And the reason this is important is whenever the source org sends the request to the target org, that issuer is how the target org knows which external client app to use in the authentication handshake. The subject is the user you want from the target org to authenticate as, and then the audience is test.salesforce.com for sandboxes and login.salesforce.com for production instances. Do not use your my domain. It's a little bit of a weird quirk, but that audience does not actually it's not where the endpoint goes. That's just a kind of placeholder. So it's always those two values for prod and sandboxes respectively. The only other thing we have to do on the external credential is choose that the certificate bundle from certificate and key management that we created in the source org just a second ago. So we're going to specify that. And then with that, we're done with the external credential, and now we're moving on to setting up the name credential. The name credential in this case, and then in the new version of name credentials, is super basic. The only thing we provide is the endpoint that we're wanting to call, which in this case I'm providing just the base sandbox URL because I'm going to be doing a simple query against the org, and then specifying the external credential we just created. And that's it. And with just that little bit of setup, right, we are now able to actually call out to another org. And so if you've never done this before inside of Apex, right, we're just doing a simple HTTP request. And inside of the endpoint, I'm specifying callout, colon, and then the name of my name credential, the API name of it. What's going to happen is when Salesforce evaluates that and makes the callout, it's going to merge in the endpoint from the name credential, right? And then it's also going to perform the authorization handshake using the details in the external credential and execute that. So this is really nice because inside of Apex, you don't have to do any work to do your own authorization flow. You're just specifying that callout, colon, and the name of the name credential, and then the platform handles the rest for you. And if that kind of seems crazy, like I said, if you haven't used this before, it's a little bit weird just seeing that in there, but the platform's evaluating that for you. And then you can kind of see down there at the bottom, we actually got a response back from the org, and we got the return from the query. So relatively quickly, we were able to securely connect two orgs together and get data back from them. That is really neat and super interesting, but now what I want to do is talk about why it works and why it's secure, because a lot of times in Salesforce, I think we go right for the answer, and we don't understand all the time about why is it, and maybe whenever someone challenges us from security and says, hey, why is this secure, we can't really articulate that, and so that's what I'm going to tell you a little bit about now. So to kind of do that, we need to talk about encryption a little bit. And so the first thing we're going to talk about is symmetric encryption. This is how encryption kind of worked for a really long time, up until the early 1970s, which is we have a secret key that we share between two people, and we're going to use that same secret key to encrypt and decrypt documents. So someone takes something that's plain text, we can encrypt it using our secret key, and then the same person can take that secret key and decrypt it. The biggest problem with this is how do you share the secret key securely? Because if someone gets that secret key, they can decrypt anything and encrypt anything with no bounds, right? And so this, in the previous world, this wasn't so bad, but whenever you start looking at computing applications, something like HTTPS, which is how your browser securely exchanges information with a website, if you're sharing that secret key over the same internet connection as your browser, well, if an attacker has already compromised that internet connection, you probably can't safely secure or exchange that key over that same route. And so this was a big problem, and thankfully someone solved it for us in the early 1970s with a concept that's known as asymmetric encryption. And so what this does is it splits a key into two pieces, which is a public key and a private key. The idea being is a public key can be freely distributed. We don't care if everyone in the world has it. There's nothing wrong with that. But we have another piece of it called the private key that we keep secure to ourselves, and we hide that, and we don't let anyone see that. And what we can do with that, in this example, is Astro can take a plain text document, he can take Cody's public key, he can encrypt that plain text document into an encrypted document, send it to Cody, and then Cody can decrypt that data using his private key. Now, if Astro encrypts that document, someone else with the public key cannot decrypt it. It's a one-way street, basically, right? And so this was a huge benefit because this is how HTTPS works with your browser. The website offers up a public key, which is called the certificate. You might have seen a certificate error in your browser before, right? It offers up a certificate to your browser. Your browser uses that public key to encrypt all the data, and then the website keeps that private key secret, and only they can decrypt the data. So this was a huge thing, and it's very important to modern day computing. And why does it matter at all to what we're talking about right now? And it's because the opposite of this is what's called a digital signature. So what if we don't need to hide the data? What if we're just really concerned about knowing who it came from? So if you think about the authentication flow I just described, the data that we're sending to that target system, there's no PII in it. It's a consumer key, it's a username, it's really basic stuff. It's nothing that we care someone else getting a hold of. But what we need to know is we need to know that it came from that target or from the source system. We have to know who it came from. And so what we can do is in reverse, Cody can take a plain text document, using his private key, he can create a signature on that document, And when he sends that to Astro, Astro can use that public key that's freely distributed to verify the signature and know that it came from Cody. So in this scenario, it's almost like if I had signed a document, right, and then we had like a forensic scientist come in and look at the signature and say, yeah, that definitely was Clay's signature. That's the equivalent of what we're doing here. And so then where that comes in, if we kind of look at the overall flow of this, right, is if we kind of use Cody as our source system and Astro as our target system, Cody's going to generate a JWT. He's going to sign it using his private key, send it to Astro. Astro then verifies that using Cody's public key, and he now knows, because of that it came from Cody 100%. He can be so sure of that. He'll then generate an access token and send that back to Cody. Right? So the idea is that this cryptographic principle, and if you're interested in, like, if you're kind of like unsure about that and you're like, I don't believe that. Like, that seems a little bit unbelievable. I'd love, like, definitely come talk to me afterwards. I'd love to dig in more about like the details of why. But this is extremely secure, and it's something that like fundamentally has never been broken, this concept. So because of that, that system can now return that access token to Cody with 100% certainty that that original request came from Cody. So now we're going to go back to our system landscape real quick, and we're going to tie this back together, right? Which is inside of that source system. When I was talking about certificate and key management, that is where that private key is being stored. And on the right-hand side in our target system, on the connected app or the external client app, that's where the public key is being stored, right? And so those two pieces together, because the source system signed that request and we have the public key on the target side, we know it came from that source system. And that is what enables this to be a completely no user involved process, server to server, without any interaction, is because just by that, we only have to basically do a one-way authentication handshake. We don't have to like bounce back and forth between the systems, because the cryptographic principle ensures us that it came from the source system. So just kind of like to pause here on this like a little bit, I'm showing Salesforce to Salesforce, and I talked about it a little bit at the beginning. This doesn't have to be Salesforce to Salesforce. You can replace either side of this with a different system, right? And the idea is whichever side you replace, the other side that's left as Salesforce, those same pieces is what you would use. So like, let's say you're having AWS connect into Salesforce. On your target system, you're still going to need a connected app or an external client app with a public key, right? If you flip it and you have Salesforce calling into AWS, on the source system, you're still going to need a name credential, an external credential, and you're going to need a certificate bundle, right? So you can kind of think you can replace either of these, and the pieces kind of stay the same. So with that, that's really all I had. There's some resources here. I talked about the setup of how you do name credentials, how you do external client apps, and the OAuth endpoints. That's kind of that endpoint that I was talking about there at that one point. I'm going to be around here for a little bit. If you have any questions, like I said, I'd love to talk more about it. But thank you all for coming and making me the last session of your day, and have a happy rest of your Dreamforce.